Okay, welcome to this supplementary example on review from grade 11 dynamics. This is one of the harder examples that we would have done, or harder questions we would have done in the grade 11 course. And we're going to go through it here on the video. Please get your handout out so you can look at it, because I don't have the question written down. So this is number 4. I am walking my 10 kilogram pug Charlie. That's the question we're looking at, and you might want to make notes as we go along because this is a harder question, but it's one that you should be able to handle for the grade 12 course. All right, so in this question, I've got my 10 kilogram pug Charlie. He stops to sniff a tree, and I want to get him moving. So I apply a force on an angle. So if you picture, here's the tree, here's Charlie sniffing away, and me, I want to get going. So I'm applying a force of 65 newtons on a 30-degree angle. And I just barely get him going by applying that force. So if I just get him going, if that's true, then my applied force in the direction of motion must be equal to Fs. And that becomes sort of the basic idea of the problem. Fs, of course, is static friction. So if you're just starting something moving, I'm just overcoming static friction force to get going. I'm applying it just enough. And that would be, and I say X because the force I'm applying in the X direction.
For a message, please. Sarah Brown to the office.
The force I'm applying in the direction of motion, hopefully I'm not lifting Charlie up. So this would be my FAX, and this is my FA. So the force I apply in that direction is just enough to get him going. So the question has several parts to it. And sort of on the next page, we'll start working through all of the parts. But that's the basic idea of the problem. Okay, so part A asks us to draw a free body diagram. That would be on Charlie. So if I draw Charlie here, the circle represents Charlie. And I'm going to list all the forces acting on him. Easiest one to begin is gravity, which remember is equal to mass times 9.8. There's a normal force acting on Charlie. Charlie's sitting on the ground, so some force is pushing up on him. So that's normal. If this is the direction of motion, that's where I'm pulling him. There must be a static friction force holding him back. And you might remember that I try to avoid drawing angled forces on free body diagrams. So I'm going to draw FAX. This is my applied force in the horizontal. And there's FAY, because I pull up a little bit as well. So that's my free body diagram. In part B, very simply asks us to find the gravity force acting on Charlie. So Fg equals mg equals his mass of 10 kilograms times 9.8 newtons per kilogram. Now that we're talking about dynamics, we'll express G in terms of the gravitational field constant, which is force per unit mass, newtons per kilogram. Just remembering that kilograms cancel, so I end up with a newtons. So his force of gravity is 98 newtons. Okay, that's part B. Part C says find FAX and FAY, or FAX, FAY. So part C. Just remembering, I'm pulling up with 65 newtons and picturing force as we do with all vector quantities as having x and y components. This is 30 degrees. FAX must be 65 cos 30, and FAY equals 65 sine 30. Just thinking in terms FAX is adjacent to the angle, so because it's adjacent to the angle, it's going to be cosine, and because FAY is opposite the angle, it's going to be sine. I could go ahead and solve those with decimal places, but it's actually more accurate to leave it like this for the time being. Part D asks us to find the normal force. So recalling the free body diagram, in the up and down direction. We've got FG down, which is 98 newtons. And we've got up, we've got normal. And we also have FAY, which is 65 sine 30 in the up direction. So when you find normal, you use the guiding principle is that up force equals down force. You're assuming there's no motion in this case. If it was accelerating up or down, that'd be different, but when you're on a solid surface like the ground, up equals down. So up equals down. Unbalanced, that means my normal plus FAY equals FG. So normal equals 98. Take away 65 sine 30. And the normal force is equal to about 65.5 newtons. Actually, exactly 65 newtons. Alright. So there's normal force. If I'm going too fast, please take a moment and stop, write down the example, and sort of think about where the numbers are coming from. If you feel like I'm jumping a few steps, you should work through the problem on your own. Okay, part E is static friction force. Okay, to find the static friction force, there's two ways you could do it. The first one is using the formula for static friction. The second way is to use the free body diagram, where we have static friction going this way, and we have FAX. Actually, I just wrote that backwards. But static friction is pulling them back, and FAX is pulling them forward. Keeping in mind that they're equal and opposite to each other in this case, because when you just start to move you're just having enough to overcome static friction. So static friction is here. So every time you solve for static friction, you basically have this choice. You can use the free body diagram, or you can use the formula. Now I say it's a choice, but it's not really. And the reason it's not really a choice is because we don't know this. We don't know coefficient of friction. So really you can't use this method. We're going to have to come down and use the free body diagram. So, because Fs equals Fax, very simple, the static friction force then is equal to 65 cos 30 degrees. Okay? And again, we could solve with the number, but it's okay to leave it like this as well, because it's actually more accurate. So there's Fs. Finally, in part F, it wants us to find the coefficient of friction. Well, I have to remember I gave you that formula. Okay. So we know Fn from earlier in the problem. And we know Fs from earlier in the problem. So really we just solve from US. And US equals Fs by Fn. 65 cos 30. By 65, and it ends up being approximately equal to 0.86. And we know it's a good answer because it's between 0 and 1. Okay, so there's a lot of steps there, and I do suggest you go through the whole problem yourself and make sure you can follow the train of thought, but if you can, that's one method of solving for coefficient of friction.